For problem number 4, we've got a circuit, and it's got 12 volts, a 12-volt battery with a 24-ohm resistor, and a 0.15 Henry inductor, no current in the circuit, and the switch is open. So after the switch is closed, what is the voltage across the resistor and the inductor? So as soon as the switch is closed, what we want to think about is the fact that we've got this inductor that opposes the initial current. So we know that the current will start at 0 and steadily increase over time. But just after the switch is closed, if the current is 0, then the voltage across the battery, which is IR, is going to be 0 times R, which is also 0. So that would be the, this should be the resistor. Okay, for part B, a long time after the switch is closed, what's the voltage across the resistor? So we're going to look at this, and after a long time, we're going to look at the inductor as if it's just a wire, so it doesn't cause any resistance and it doesn't have any voltage, any sort of potential difference as the current goes through it. And so we can treat this as, we can use Kirchhoff's law to do this, but just visually you can see that because there's only one element, if we have a positive voltage, that element's going to absorb or dissipate all the voltage in the battery, and then it's going to come back to 0. So using Kirchhoff's loop rule, we start with the 12-volt EMF. We subtract the voltage that goes through the resistor. We treat the inductor as a regular wire, so everything equals 0, and then the voltage through the resistor is equal to 12. Okay, part C. What is the current in the circuit when equilibrium is reached? So in this scenario, we are going to, since we have this point of equilibrium right here, we know that that is going to be the equation V equals, or I equals V over R. And so we plug in our voltage and our resistance, and that gives us 0.5 amps. So you can basically look at this equation and set that equal to IR and get your same answer. So part D, how much energy is stored in the inductor when equilibrium is reached? So U is equal to 1/2 Li squared. And we've got the inductor of 0.15 hertz. The current is 0.5 amps squared, and that gives us 0.019 joules.